another is the cost function. Okay. And in a two variable factor case, the conditional factor demands are xi, it's just x1 is equal to d1 demand function, depends on price of first factor and price of the other factor, and output level. You know, we assume the cost minimizing firm has an output target. See, the firm has to produce a certain level. Okay. X2 is equal to B2 R1 R2 Y. Okay. And those are kind of derived from the firm's cost minimization problem. Okay. They're derived concepts. And we also have this cost function. C is equal to, little c is a function, okay? R1, R2, and Y. Okay. So remember the C, the cost, is the minimal cost to produce Y, given the factor prices. Okay. So which is different from the R1 X1 plus R2 X2, the cost, variable cost we defined earlier. You know, let me use a graph to show that. If this is the ISO cost line, you know, if these are the ISO cost line, okay, this is the ISO points. Y is the target level of output. Okay. Then this is X1. This is the X2, the optimal cost minimizing. And C, the slope of this ISO cost line is R1 over R2. That's given. Okay. Prices are taken as given. And then this point is C over R2. Okay. So the factor demands basically means, okay, if I know R1, R2, and Y, then I can find the optimal input combination X1, X2. But writing this 2 as a function is as if you are solving an infinite number of cost minimization problems. For each set of values for R1, R2, Y, you can get a combination of X1 and X2. Okay. All right. So let me use an example. Suppose R1 increase a little bit. The slope of the ISO cost line is going to increase, correct? So on my X1, X2, both are going to change, move a little bit towards this direction. Okay? So that's so-called the comparative statics analysis. Okay? You want to predict how the behavior will change in response to a change in the decision-making environment, R1, R2, and Y. Okay? And similarly, when you change R1, R2, or Y, this minimal cost, C, will change, correct? Using the previous example, if you increase R1, so your ISO cost line will move in this direction, so your new cost, minimal cost will go up a little bit. Okay? So that's the idea. Those concepts are derived. Okay, derived from a cost minimization problem. And we also gave kind of a study some of the property of these functions. Okay, for example, this X1 always increase when you decrease the price of that factor. It's a law of demand. Okay, and when the price of the other factor increase, you're going to increase the demand for that factor. You know, by substituting this factor for the more expensive factor. Okay. And similarly, we did some analysis of the cost function. There's a very important property of the cost function is the partial of this function with respect to the first price is X1, is D1. Okay. And the partial of this function with respect to second price is D2. Okay. That's a very powerful result. Okay, that means there's, as we emphasized earlier, understanding this factor demand function is very important in terms of natural resource management, input management. A lot of the policy questions are related to this, because if you want to predict how the producers are going to use the resources in production, you got to understand these functions, correct? So we introduced kind of 3 ways to estimate this function. One is if you have this data on input price and input quantity and output level, you can directly estimate those functions. Okay. Secondly, if you have quantity, output quantity and input quantity, what you can do is to estimate the production function. Then derive this cost minimizing input functions from the production functions. Okay, so we have shown how to do that. The third approach is directly estimating the cost function. Okay, so when you have the cost data, you have the market price data for inputs, you have the output level, you can estimate this cost function and take the partial derivative of that estimate function. You can also get the input demands. Okay, so this theory, the theoretical analysis gives us kind of a variety of ways to estimate the factor demand. Okay. But what we have done so far basically mainly focus on how those economic outcomes change when you change the prices, input prices. We haven't really handled how those costs are going to change in response to Y. Okay. So, but we have kind of did a little bit analysis in terms of looking at different Y levels, and we derived this so-called expansion path. Remember, when you change the Y level, your cost minimizing input combination are going to change. Okay. So what we are going to do now, okay, is to kind of have a closer investigation of how those costs, okay, are related to the Y, the output target. Okay, and this kind of brings back, hopefully brings back some of your analysis done in undergraduate production microeconomic courses. Remember, we have a marginal cost function, average cost. Okay, all of these cost functions are related to this cost function. Okay, although usually it's not explicitly stated in the undergraduate microeconomic course. So now we're going to have a closer look at those concepts. The marginal cost curve, remember, you remember this. This is the Y, this is the marginal cost. And this is the average cost. Marginal cost goes this way. Remember this? Okay. And where's the firm's optimal production Y? Production level Y. Remember, we did this analysis. Okay. But we never understood how those cost curves are, where these cost curves are from. Okay. In the undergraduate course, usually we don't talk about that. But right now, we're going to look at that. Okay. So that's the purpose of today's analysis. Essentially, what we're doing still is conduct a comparative statics analysis. Remember, the definition of comparative statics analysis is to see how economic outcome changes when the decision-making environment, some exogenous shock. Okay, what's changing here is the output target. Okay, to give an example, think about the public utility like an electricity firm. Okay, so usually electricity firm is trying to satisfy the demand for a region, correct? But imagine suddenly there's a rising demand for electricity in the region. So how would that firm respond to this change in the demand? Okay, so the firm is going to change the Y output produced, electricity